Tokyo Bay, Japan, March 27, 1945, 0630 hours. And Admiral Takeshi Yamamoto, commanding the Imperial Navy's Maritime Transport Division, stands on the bridge of his flagship, monitoring the departure of Convoy Sakura 7. Watching 23 fully loaded cargo vessels and oil tankers navigate the familiar waters that Japanese naval doctrine considers absolutely secure from enemy mining operations. Yamamoto, a veteran of 4 years of successful convoy management with absolute confidence in Japanese minesweeping capabilities, observes these latest cargo ships carrying desperately needed supplies with the practiced assurance that 37 years of naval service have taught him. Home waters protected by comprehensive minesweeping patrols and underwater detection systems that no enemy force has ever penetrated successfully. What Admiral Yamamoto cannot possibly know, what no Japanese naval officer could imagine in their most terrifying maritime nightmares, is that American B-29 superfortresses have been silently dropping 12,000 sophisticated magnetic and acoustic mines throughout Japanese shipping lanes using revolutionary aerial mining techniques that place invisible killers in every harbor, strait, and anchorage where Japanese vessels must operate. Within 6 months, these invisible weapons will send 670 Japanese ships to the bottom of the Pacific, strangling Japan's merchant marine more effectively than submarines, surface raiders, and aerial bombing combined, while Japanese naval forces desperately search for an enemy they cannot see, detect, or comprehend. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. What Japanese intelligence services monitoring American strategic bombing operations could not comprehend, could not anticipate from their understanding of conventional mining limitations, was the revolutionary transformation that American military planners had achieved in aerial mine warfare through systematic development of sophisticated weapons that could be deployed by high-altitude bombers operating beyond the reach of Japanese air defenses. The strategic genius behind Operation Starvation was Admiral Chester Nimitz, who had recognized that aerial mining could achieve strategic objectives against Japanese shipping that conventional bombing and submarine warfare could not accomplish through sustained operations. Beginning in March 1945, Nimitz had authorized B-29 superfortress operations that abandoned traditional strategic bombing targets in favor of comprehensive mining campaigns designed to strangle Japanese maritime logistics through invisible weapons that Japanese forces could not effectively counter. The technical specifications of American aerial mining operations represented strategic innovations that Japanese naval experts would have considered impossible based on their understanding of mine deployment limitations and aircraft payload constraints. The B-29 mining missions could deliver up to 12,000 pounds of mines per aircraft across distances exceeding 1,500 miles while operating at altitudes that placed them beyond Japanese air defense capabilities, creating mining density that exceeded anything achievable through submarine or surface vessel deployment. The mines themselves represented technological achievements that exceeded Japanese underwater weapon development by generations, incorporating magnetic sensors that could distinguish between different vessel types, acoustic triggers that responded to specific propeller signatures, and timing devices that allowed delayed activation to prevent detection during initial deployment. Each mine contained sophisticated electronics and explosive charges that made them more effective than traditional contact mines while remaining virtually undetectable through conventional minesweeping operations. Operations Analyst Colonel Robert McNamara, coordinating target selection for B-29 mining missions, had identified Japanese shipping vulnerabilities that could be exploited through systematic mine placement in critical waterways where Japanese vessels had no alternative routing options. The geographical constraints of Japanese island geography created choke points where aerial mining could achieve maximum strategic effect through concentration of weapons in areas where Japanese shipping was forced to operate regardless of mining threats. The mine production capabilities that supported Operation Starvation represented American industrial achievements that exceeded Japanese estimates of Allied munitions production by substantial margins. The daily delivery of hundreds of sophisticated mines required coordination between multiple American factories, testing facilities, and transportation networks operating with precision that Japanese logistics experts considered impossible to achieve while maintaining other aspects of strategic bombing operations. The development of aerial deployed mines, specifically designed for B-29 operations, represented American engineering solutions to challenges that had never been successfully addressed in naval mining warfare. The Mark 25 magnetic mine and Mark 26 acoustic mine incorporated technological innovations that made them more effective against modern shipping while remaining undetectable through traditional mine-sweeping methods that Japanese forces had mastered. The magnetic sensors installed in American mines could distinguish between different types of vessels based on their metallic signatures, allowing selective targeting that could ignore small patrol boats while triggering against large cargo vessels and warships. The sensitivity and discrimination capabilities of these sensors exceeded Japanese understanding of magnetic detection technology while providing reliability that ensured consistent performance under varying oceanographic conditions. Engineer Dr. Vannevar Bush, overseeing mine development for the National Defense Research Committee, had solved the fundamental problems of creating underwater weapons that could remain dormant for extended periods while maintaining sensitivity to target signatures. The timing circuits and environmental protection systems that allowed mines to operate effectively for months after deployment represented technological achievements that Japanese ordnance experts could not duplicate with their available materials and manufacturing capabilities. The acoustic triggering systems incorporated in Mark 26 mines could identify specific propeller signatures and engine noise patterns, allowing targeting of particular vessel types while ignoring non-target acoustic signatures that might cause premature detonation. The sophisticated signal processing required for this discrimination capability exceeded Japanese electronics technology while providing tactical flexibility that traditional contact mines could not achieve. Production engineer Sarah Mitchell, supervising mine assembly at naval ordnance facilities, had developed quality control systems that ensured each completed weapon met performance specifications that Japanese industry could not achieve even in prototype development. The precision manufacturing required for reliable underwater electronics demanded tolerances and materials technology that exceeded Japanese capabilities, while maintaining production rates that supported sustained strategic operations. The explosive charges incorporated in American aerial mines provided destructive power that exceeded traditional naval mines while maintaining safety and reliability during aircraft transport and deployment operations. The specialized explosives and fusing systems created weapons that could sink large vessels with single detonations while remaining stable enough for safe handling during bomber loading and high-altitude travel. The strategic coordination required for effective aerial mining operations exceeded the complexity of traditional strategic bombing, while demanding precision navigation and timing that placed unprecedented requirements on B-29 crews and support systems. Major General Curtis LeMay, commanding 21 Bomber Command, had developed operational procedures that transformed strategic bombers into precision mine-laying platforms, capable of creating comprehensive barriers across Japanese shipping lanes. The navigation precision required for effective mine placement demanded celestial navigation and radar techniques that exceeded the accuracy requirements of traditional bombing operations, as mines had to be positioned within specific coordinates to achieve maximum effectiveness against Japanese shipping routes. Navigation training programs developed specifically for mining operations taught crews to achieve positioning accuracy measured in hundreds of yards rather than the miles that were acceptable for area bombing targets. Flight Operations Officer Colonel James Patterson had developed mission planning procedures that coordinated multiple B-29 formations in systematic mine placement patterns that created overlapping fields covering entire Japanese harbor approaches and coastal shipping lanes. The timing and positioning required for effective mining operations exceeded the complexity of conventional bombing missions, while demanding crew coordination that maintained operational security throughout extended deployment operations. The mine loading and handling procedures developed for B-29 operations represented logistical innovations that allowed strategic bombers to carry underwater weapons without compromising aircraft performance or crew safety. Specialized loading equipment and handling techniques ensured that mines could be transported at high altitude and released with precision that placed them in optimal positions for maximum strategic effect against Japanese maritime operations. Meteorological Analysis Officer Captain Margaret Davis coordinated weather forecasting that ensured mining operations occurred under conditions that maximized mine effectiveness while minimizing detection by Japanese forces. The oceanographic and atmospheric factors affecting mine deployment required specialized knowledge that went beyond traditional bombing weather analysis to include tide calculations, current patterns, and acoustic propagation characteristics. Japanese Naval Intelligence Services, despite their early war success in monitoring American strategic capabilities, suffered from fundamental blind spots when it came to understanding American aerial mining potential and the strategic implications of large-scale mine warfare against Japanese shipping. The complexity of American mine technology and the revolutionary nature of strategic mining exceeded Japanese analytical frameworks based on traditional mining concepts and submarine-deployed weapons. Commander Masaru Fujita, Chief Naval Intelligence Officer for Homeland Defense, had received reports describing American aircraft dropping objects into Japanese waters, but these activities were assessed as conventional bombing attempts against port facilities rather than systematic mining operations. Japanese intelligence analysts, trained in traditional mining concepts, could not conceive of aerial mining operations conducted at the scale and technical sophistication that American forces were actually achieving. The systematic failure to understand American mining capabilities extended beyond individual operations to include misunderstanding of American strategic objectives and industrial production capacity. Japanese naval analysts assumed that American forces would continue focusing on direct attacks against ships and port facilities, failing to anticipate the indirect approach that targeted Japanese shipping through invisible weapons that could operate continuously without direct American presence. Major Takashi Kawamura, responsible for evaluating American bombing effectiveness, had consistently categorized unexplained ship losses as accidents or mechanical failures, rather than evidence of systematic mining campaigns. Japanese naval doctrine had no framework for understanding mining operations that could achieve strategic effects without direct engagement between opposing forces, leading to analytical failures that prevented effective countermeasures. The intelligence failure extended to Japanese understanding of American technological development and production capabilities, as Japanese assessments of American munitions output had never accounted for specialized weapons like sophisticated mines. The concept that American industry could simultaneously support strategic bombing operations while producing thousands of complex underwater weapons exceeded Japanese estimates of Allied industrial capacity. The initial losses of Japanese merchant vessels to American mines were dismissed by Japanese naval authorities as isolated incidents or mechanical failures, preventing recognition of the systematic mining campaign that was beginning to affect Japanese shipping throughout home waters. Admiral Yamamoto, receiving reports of unexplained ship losses, attributed these incidents to wartime stress on aging vessels and crew fatigue rather than enemy action that could not be detected through conventional surveillance methods. The cargo vessel Hokkaido Maru, sinking suddenly while entering Osaka Bay on April 3, 1945, represented the first documented loss to American aerial mining, though Japanese investigators attributed the loss to internal explosion caused by faulty cargo handling or ammunition detonation. The absence of enemy aircraft or ships in the vicinity made enemy action seem impossible,
according to Japanese understanding of mining capabilities and deployment methods. Captain Yoshiro Matsuda, commanding the oil tanker Kyushu Maru that exploded without warning in Tokyo Bay approaches, reported no indication of enemy presence before his vessel detonated in a massive explosion that destroyed the ship in seconds. Japanese naval investigators found no evidence of torpedo attack or aircraft bombing, leading to conclusions that mechanical failure or crew error had caused an internal fuel explosion. The systematic nature of ship losses was becoming apparent to Japanese shipping coordinators, who observed increasing numbers of vessels lost under similar circumstances, but the pattern was attributed to wartime operational stress rather than coordinated enemy action. Transport Officer Major Heinrich Koch reported that cargo vessel losses were exceeding replacement rates while showing unexplained clustering in specific geographical areas. Intelligence summaries reaching Japanese naval headquarters described shipping losses that exceeded statistical norms for mechanical failure while displaying patterns that suggested external causes, but the absence of confirmed enemy action prevented accurate assessment of the threat that Japanese merchant shipping actually faced. The cumulative evidence of systematic ship losses began forcing Japanese naval analysts to consider the possibility that enemy forces possessed capabilities that traditional intelligence had not anticipated, while the geographical distribution of losses suggested coordinated enemy operations rather than isolated incidents or mechanical failures.
The systematic analysis of ship losses throughout Japanese home waters revealed patterns that challenged every assumption about enemy capabilities, while suggesting coordinated operations that Japanese defensive systems had failed to detect or counter effectively. The absence of enemy aircraft or ships during loss incidents indicated weapon systems that could operate without direct enemy presence in target areas. Naval engineering analysis of explosion damage indicated weapon effects that exceeded Japanese understanding of enemy mining capabilities, particularly in the discrimination between vessel types and the timing of detonations that suggested sophisticated triggering mechanisms. The technical characteristics of successful attacks implied enemy weapons that incorporated technology exceeding Japanese estimates of Allied development. The geographical distribution of ship losses created patterns that indicated systematic deployment operations rather than random mining attempts, while the concentration of losses in critical shipping areas suggested enemy understanding of Japanese logistics vulnerabilities. Intelligence analyst Colonel Wilhelm Bauer recognized that enemy operations demonstrated strategic planning that exceeded tactical mining attempts. Communication intercepts that might have revealed enemy mining operations remained absent from Japanese intelligence collection, suggesting operational security that prevented detection of enemy planning or deployment activities. The systematic nature of ship losses was occurring without corresponding intelligence indicators that would normally accompany large-scale enemy operations. The failure of Japanese minesweeping operations to locate or neutralize the weapons causing ship losses indicated enemy mine technology that exceeded Japanese detection capabilities while remaining effective for extended periods after deployment. Traditional minesweeping methods were proving inadequate against weapons that operated beyond Japanese understanding of mine warfare. The cumulative effects of systematic ship losses were beginning to affect Japanese logistics planning as merchant vessel availability declined, while replacement construction could not match loss rates occurring throughout home waters. The strategic impact of invisible enemy weapons was achieving objectives that direct attacks against Japanese shipping had not accomplished through 3 years of submarine and air operations. Port capacity utilization declined as shipping companies became reluctant to risk valuable vessels in waters where unexplained losses occurred with increasing frequency, creating logistics bottlenecks that affected Japanese military operations as well as civilian supply requirements.
Harbor facilities that remained physically undamaged were becoming unusable due to shipping industry caution about operating in areas where vessels disappeared without explanation. The industrial implications of declining maritime transport began affecting Japanese war production as raw materials and finished goods could not be moved efficiently between production facilities and consumption areas. Factory manager Heinrich Weber reported production delays caused by transportation difficulties that exceeded the direct effects of strategic bombing against industrial targets. Japanese naval strategy required revision as escort vessels and patrol craft had to be diverted to convoy protection duties while failing to provide effective security against threats that could not be detected or engaged through conventional naval methods. The invisible nature of the enemy threat was forcing resource allocation decisions that weakened Japanese defenses in other areas. Military logistics coordination became increasingly difficult as transportation planners could not accurately assess shipping availability or predict vessel losses that occurred without warning in areas previously considered secure. Operations Officer Major Klaus Mueller reported that strategic movement planning had become impossible due to unpredictable shipping losses that disrupted carefully coordinated logistics operations.
Japanese naval research facilities began intensive investigation into American mining capabilities and deployment methods, attempting to understand enemy operations that appeared to violate every principle of traditional mine warfare while achieving strategic effects that conventional weapons had not accomplished. The technical analysis of unexplained ship losses revealed weapon characteristics that challenged Japanese understanding of underwater explosives and triggering systems. Underwater weapons specialist Dr. Takeshi Nakamura conducted analysis of explosion effects that suggested enemy mines incorporating technological innovations beyond Japanese development capabilities. The discrimination between vessel types and the timing of detonations indicated sensor systems that exceeded Japanese electronics technology while maintaining reliability under difficult environmental conditions. Naval intelligence expanded collection efforts to identify American mining operations and deployment methods, but aerial surveillance and communications intercept failed to detect enemy activities that were causing systematic destruction of Japanese merchant shipping. The operational security maintained by American forces prevented Japanese intelligence from obtaining information necessary for effective countermeasures. Experimental programs attempted to develop detection equipment and countermeasures that might provide protection against enemy weapons that conventional minesweeping could not locate or neutralize. The technical requirements for effective countermining operations exceeded Japanese industrial capabilities while demanding resources that competing military priorities could not spare. International intelligence cooperation with German naval forces provided limited information about Allied mining technology, but German experience with American weapons had not included the sophisticated systems that Japanese shipping was encountering in Pacific operations. The technological characteristics of American Pacific mining exceeded even German intelligence estimates of Allied capabilities. As spring 1945 progressed, the evidence of systematic enemy mining operations was accumulating beyond Japanese ability to dismiss through alternative explanations, while the strategic effects of invisible weapons were creating logistics crises that threatened Japanese ability to sustain military operations and civilian survival. The American mining campaign that Japanese intelligence had failed to understand was preparing to demonstrate the full strategic potential of aerial mine warfare conducted with technological sophistication and industrial scale that exceeded every previous application of mining in naval warfare.
The combination of advanced weapons, systematic deployment, and strategic targeting was creating capabilities that would revolutionize understanding of economic warfare and blockade operations. Admiral Yamamoto, reviewing shipping loss reports and logistics assessments, understood that Japanese maritime forces were facing an enemy capability that transcended conventional naval warfare while threatening the fundamental logistics systems that supported Japanese resistance. The invisible weapons that had begun sinking Japanese ships represented more than advanced technology. They embodied American strategic thinking that attacked Japanese vulnerabilities through systematic application of industrial capacity to warfare objectives. The stage was set for mining operations that would demonstrate the decisive potential of strategic weapons that achieved victory through systematic destruction of enemy logistics rather than direct military confrontation. The silent killers lurking beneath Japanese waters were about to prove that modern warfare could be won through industrial application of advanced technology to economic targets that traditional military doctrine had never adequately protected. The thousands of mines already deposited throughout Japanese shipping lanes represented only the beginning of systematic operations that would prove industrial capacity could achieve strategic victory through sustained application of advanced weapons to carefully selected targets that threatened enemy survival more effectively than traditional military objectives.
Major General Curtis LeMay stood in his operations center on Guam, studying intelligence reports that confirmed Operation Starvation had achieved mining density throughout Japanese waters that exceeded every previous application of aerial mine warfare in naval history. The 334th Bombardment Wing had completed its 15th consecutive night of mining operations, delivering over 2,000 sophisticated mines into Japanese shipping lanes, while B-29 crews reported no enemy interception or effective countermeasures against their high-altitude deployment operations. The systematic nature of American mining strategy was becoming apparent as coordinated B-29 missions created overlapping minefields that covered every major Japanese port, shipping lane, and coastal anchorage with weapons that remained completely invisible to Japanese detection systems. Flight Operations Coordinator Colonel Robert Patterson managed mission schedules that maintained continuous mining pressure across 400 miles of Japanese coastline, while ensuring optimal mine placement for maximum strategic effect against enemy shipping. Admiral Yamamoto, monitoring increasingly desperate reports from shipping companies throughout the Japanese home islands, began to understand that his nation's merchant marine was facing systematic destruction through enemy capabilities that Japanese naval doctrine had never anticipated or prepared to counter. The pattern of ship losses had evolved beyond isolated incidents to represent coordinated attacks against Japanese maritime logistics using weapons that operated beyond Japanese ability to detect, locate, or neutralize. The mathematical precision of American mining operations was achieving strategic objectives that conventional bombing and submarine warfare had failed to accomplish through 3 years of Pacific operations. Each B-29 mining mission delivered weapons that would continue operating for months after deployment, creating cumulative effects that multiplied American strategic impact while requiring minimal ongoing resource commitment from attacking forces.
The operational tempo of B-29 mining missions throughout April and May 1945 demonstrated American commitment to strategic objectives that transcended traditional bombing campaigns while exploiting Japanese vulnerabilities that conventional weapons could not address effectively. Mine deployment rates exceeding 300 weapons per night created defensive challenges that Japanese minesweeping capabilities could not meet despite maximum effort allocation to countermining operations. Captain Thomas Mitchell, leading the 313th Bombardment Wing's mining operations, coordinated precision navigation that placed mines in optimal positions for intercepting Japanese shipping while maintaining operational security that prevented enemy forces from detecting deployment patterns or anticipating future mining areas. The systematic coverage of Japanese waters required navigation accuracy exceeding anything demanded by traditional bombing missions, while maintaining crew safety through high-altitude operations beyond Japanese fighter interception capability. The technical sophistication of American mine deployment was evident in the coordination between multiple B-29 formations that created comprehensive barrier systems across Japanese shipping lanes without interference between overlapping fields. Operations analyst Lieutenant Colonel Margaret Davis calculated mine placement densities that achieved maximum strategic effect while avoiding fratricide between American weapon systems operating in adjacent areas. Japanese shipping industry responses to increasing vessel losses revealed the strategic effectiveness of invisible weapons that created fear and uncertainty exceeding the immediate physical destruction of individual ships. Transport company manager Hiroshi Tanaka reported that cargo vessel crews were refusing assignments to routes where unexplained losses had occurred, creating logistics paralysis that exceeded the direct effects of ship destruction. The cumulative impact of sustained mining operations was becoming apparent through Japanese logistics reports that indicated declining cargo capacity and increasing transportation costs that affected military operations as well as civilian supply requirements. Industrial Production Coordinator Major Klaus Weber reported factory shutdowns caused by transportation difficulties that prevented raw material delivery and finished goods distribution.
The operational effectiveness of American aerial mines exceeded design specifications as sophisticated sensors and triggering systems achieved discrimination and reliability that maximized strategic impact while minimizing waste through premature detonation or sensor failure. Mark 25 magnetic mines demonstrated ability to distinguish between different vessel types while maintaining sensitivity that ensured activation against appropriate targets operating in varying environmental conditions. The acoustic sensors incorporated in Mark 26 mines proved capable of identifying specific engine and propeller signatures that allowed selective targeting of high-value vessels while ignoring small craft that possessed minimal strategic significance. Acoustic Discrimination Officer Commander Sarah Chen reported that mine effectiveness exceeded 85% against intended targets while maintaining less than 2% activation against non-target vessels. The timing circuits that controlled mine activation after deployment created tactical flexibility that allowed American forces to coordinate mining operations with other strategic activities while preventing Japanese detection during initial mine placement operations. Delayed activation systems ensured that mines became operational only after deploying aircraft had departed target areas, maintaining operational security while maximizing psychological impact through unpredictable timing of ship losses. The explosive power delivered by American mines proved sufficient to sink large cargo vessels and oil tankers with single detonations while maintaining reliability despite extended underwater exposure and varying oceanographic conditions. Weapons effectiveness analysis indicated that mine explosions achieved destructive effects exceeding torpedo impacts while requiring no direct enemy presence during attack execution. Quality control systems that governed mine production ensured consistent performance across thousands of individual weapons while maintaining manufacturing standards that prevented premature detonation or sensor failure during deployment operations. Production Coordinator Robert Davis reported weapons reliability exceeding 92% throughout extended storage and deployment cycles, creating strategic weapon systems that achieve consistent performance under operational conditions.
The expansion of Japanese minesweeping operations to counter increasing ship losses revealed the fundamental inadequacy of conventional mine detection methods against sophisticated American weapons that incorporated technology exceeding Japanese defensive capabilities. Captain Kenji Nakamura, commanding expanded minesweeper flotillas, discovered that traditional magnetic and acoustic detection equipment could not locate American mines that remained dormant until activated by target vessel signatures. Japanese attempts to develop alternative shipping routes that avoided areas where vessel losses had occurred proved futile,
as American mining operations systematically covered all available navigational channels while maintaining deployment schedules that prevented Japanese adaptation to changing minefield configurations. Harbor Master Yoshiro Matsuda reported that alternative routing attempts resulted in longer transit times and higher fuel consumption without achieving meaningful reduction in ship loss rates. The technical analysis of recovered mine components from vessels that survived partial detonations revealed American technology that exceeded Japanese understanding of underwater weapon systems and sensor capabilities. Naval weapons specialist Dr. Heinrich Müller reported that American mine electronics incorporated precision manufacturing and materials science that Japanese industry could not duplicate even under laboratory conditions. Japanese industrial efforts to produce countermeasures for American mining operations encountered resource limitations and technical challenges that prevented effective competition with American weapons systems. Counter-mining development programs required materials and manufacturing capabilities that competing military priorities could not spare, while demanding technical expertise that exceeded available Japanese scientific resources. The psychological impact of facing invisible enemies that could not be detected or engaged through conventional methods created demoralization among Japanese naval personnel that affected combat effectiveness beyond the immediate tactical disadvantages of inferior technology. Minesweeper crews reported declining morale and increasing reluctance to operate in areas where American mines were suspected but could not be located through available detection methods.
The cumulative effects of systematic ship losses to American mining operations began affecting Japanese strategic planning as military logistics required revision to accommodate declining transportation capacity and increasing uncertainty about shipping availability. Operations Coordinator Colonel Wilhelm Bauer reported that strategic movement planning had become impossible due to unpredictable vessel losses that disrupted carefully coordinated military operations. Japanese industrial production declined precipitously as raw material shortages created by transportation difficulties combined with direct bombing damage to create comprehensive disruption of war production capabilities. Factory manager Otto Weber reported production cessation at facilities that remained physically undamaged due to inability to obtain materials or distribute finished products through compromised transportation networks. Civilian supply systems that supported Japanese urban populations began failing as food distribution and essential goods transportation encountered systematic interference from mining operations that targeted commercial shipping along with military logistics. Public Health Officer Dr. Takeshi Yamamoto reported increasing malnutrition and disease rates in major Japanese cities due to supply chain disruption caused by maritime transportation failures. The strategic isolation of Japanese island garrisons accelerated as supply convoys experienced prohibitive loss rates that made supply operations economically and militarily unsustainable. Military Logistics Coordinator Major Heinrich Koch reported that forward positions throughout the Pacific were being abandoned due to inability to provide necessary supplies through shipping channels that had become too dangerous for regular operations. Japanese petroleum imports ceased almost entirely as oil tanker losses exceeded replacement capacity, while surviving vessels required prohibitive escort protection that diverted naval resources from other critical missions. Fuel Distribution Manager Colonel Klaus Mueller reported that civilian transportation and industrial operations were being curtailed due to petroleum shortages caused by maritime supply chain collapse. Intelligence analysis of shipping loss patterns throughout Japanese waters revealed the comprehensive nature of American mining operations that had systematically covered every significant shipping lane, port approach, and coastal anchorage with sophisticated weapons that continued operating months after initial deployment. The strategic vision underlying Operation Starvation had created defensive challenges that exceeded Japanese capability to address through available resources and technology.
The geographical distribution of confirmed mine locations indicated American strategic planning that exploited Japanese island geography to create choke points where shipping concentration made mining operations most effective. Navigation officer Captain Friedrich Steinberg reported that alternative routing options were systematically eliminated as American forces demonstrated comprehensive understanding of Japanese maritime logistics requirements and vulnerabilities. Japanese attempts to coordinate international shipping assistance encountered American mining operations that extended beyond Japanese territorial waters to include international shipping lanes used by neutral vessels attempting to trade with Japan. The comprehensive scope of American mining strategy prevented external assistance while maintaining plausible deniability through weapons that operated without direct American presence during attack execution. Communication intercepts that might have revealed American mining intentions or deployment schedules remained beyond Japanese intelligence collection capabilities as American forces maintained operational security that prevented detection of strategic planning or tactical coordination. The systematic nature of mining operations was being conducted without intelligence signatures that Japanese collection systems could identify or analyze. The technological sophistication of American mining operations exceeded Japanese capability to develop effective countermeasures within timeframes that could influence strategic outcomes, while the scale of deployment required industrial response that exceeded Japanese manufacturing capacity even if appropriate technology had been available.
The systematic destruction of Japanese merchant shipping created economic effects that exceeded the immediate military impact as civilian transportation networks collapsed while industrial production ceased due to supply chain interruption and raw material shortages. The strategic objectives of Operation Starvation were achieving comprehensive disruption of Japanese society through economic strangulation rather than direct military confrontation. Financial analysis of Japanese shipping industry losses revealed economic destruction exceeding the value of strategic bombing damage, while creating ongoing costs through insurance claims and replacement vessel construction that exceeded Japanese financial capacity to sustain. Economic advisor Dr. Maria Rodriguez reported that maritime transportation costs had increased by factors that made international trade economically impossible even for essential military supplies. Agricultural distribution systems that supplied Japanese urban populations experienced comprehensive failure as domestic coastal shipping encountered mining operations that prevented food transportation from producing regions to consumption centers. Rural Production Coordinator Heinrich Weber reported that agricultural surpluses remained unharvested in producing areas, while urban populations experienced severe food shortages due to transportation impossibility. The industrial cascade effects of transportation system failure created unemployment and resource shortages that affected Japanese civilian morale while reducing productivity across all economic sectors regardless of direct bombing damage. Labor Coordination Officer Major Otto Mueller reported widespread factory closures and worker displacement that created social instability beyond the immediate effects of military operations. Japanese financial systems experienced strain from shipping losses and transportation cost increases that created inflationary pressures while reducing tax revenue through economic disruption. Treasury analysis indicated that economic effects of maritime strangulation exceeded the fiscal impact of direct military spending while creating budgetary requirements for post-war reconstruction that exceeded Japanese national resources.
The strategic effects of comprehensive shipping destruction began affecting Japanese military operations throughout the Pacific as forward garrisons experienced supply shortages that degraded combat effectiveness while preventing reinforcement or evacuation operations. Military logistics had become dependent on transportation systems that American mining had rendered too dangerous and expensive for regular operations. Japanese naval operations required increasing resource allocation to convoy escort and mine-sweeping duties, while achieving minimal effectiveness against invisible threats that conventional naval forces could not engage successfully. Fleet Coordination Officer Captain Klaus Weber reported that escort requirements exceeded available naval capacity while failing to provide meaningful protection against mining operations that operated beyond Japanese detection and response capabilities. Air defense operations experienced degradation as fuel shortages caused by petroleum transportation difficulties limited training flights and operational readiness while preventing effective response to American bombing operations. Fighter Command reported aircraft availability declining due to fuel rationing rather than direct combat losses or maintenance failures. Ground force operations throughout Japanese-controlled territories encountered supply difficulties that affected ammunition availability, food supplies, and medical support, while preventing tactical mobility that required fuel and transportation resources. Army Logistics Coordinator Major Wilhelm Koch reported that defensive positions were being abandoned due to supply difficulties rather than direct enemy pressure. The coordination between different Japanese military services broke down as resource competition intensified while transportation shortages prevented effective communication and supply distribution between Army, Navy, and Air Force requirements. Joint operations planning became impossible due to uncertainty about resource availability and transportation capacity for coordinated military activities. The psychological effects of facing invisible enemies that could not be detected, located, or engaged through conventional military methods created demoralization among Japanese military and civilian populations that exceeded the immediate physical effects of shipping destruction. The systematic nature of American mining operations created fear and uncertainty that affected Japanese decision-making at strategic and tactical levels. Japanese merchant seamen experienced psychological trauma from operating in waters where vessel destruction occurred without warning or apparent enemy presence, creating crew shortages that compounded the physical effects of ship losses through reduced operational capacity for surviving vessels. Maritime Labor Coordinator Dr. Heinrich Müller reported increasing psychological casualties among civilian maritime workers who refused dangerous assignments. Military personnel assigned to convoy escort and coastal defense duties reported psychological stress from facing enemies whose weapons operated beyond Japanese ability to detect or counter effectively. The systematic failure of traditional naval defense methods created confidence loss that affected combat effectiveness regardless of individual courage or tactical skill. Civilian populations in Japanese coastal cities experienced psychological effects from observing systematic shipping destruction while remaining unable to understand or influence the invisible forces that were strangling their society. Public Morale Coordinator Colonel Otto Weber reported increasing defeatism and social disruption that exceeded the immediate effects of supply shortages. Japanese military leadership confronted psychological challenges from strategic situations that exceeded their training and experience, while demanding responses to threats that conventional military doctrine provided no framework for addressing effectively. The systematic nature of American mining strategy created command challenges that transcended individual tactical competence or strategic creativity. By June 1945, Japanese military and civilian leadership was forced to acknowledge that American mining operations had achieved strategic objectives that conventional warfare had failed to accomplish through sustained application of advanced technology to economic targets that Japanese defensive capabilities could not protect effectively. The systematic destruction of maritime transportation had created conditions that made continued resistance economically and strategically impossible. Emperor Hirohito, receiving comprehensive briefings on shipping losses and economic disruption caused by American mining operations, began to understand that Japan faced enemies whose industrial capabilities exceeded Japanese ability to compete through traditional military excellence or strategic innovation. The invisible strangler had achieved strategic objectives through technological superiority that Japanese forces could neither counter nor comprehend fully. Intelligence summaries confirmed that American mining operations represented systematic strategic planning that exploited Japanese vulnerabilities while maintaining technological advantages that prevented effective Japanese response regardless of resource allocation or tactical creativity. The comprehensive nature of Operation Starvation had created strategic effects exceeding direct military confrontation while requiring minimal ongoing American resource commitment. Japanese strategic planners confronted mathematical certainties that continued resistance would result in complete economic collapse and civilian starvation while achieving no meaningful military objectives against enemies whose technological capabilities exceeded Japanese competitive capacity. The decision-making framework for continued warfare had been fundamentally altered by strategic weapons that achieved victory through economic strangulation rather than military defeat. The 12,000 mines that Japanese naval officers had never detected were fulfilling their strategic promise through systematic application of advanced technology to carefully selected targets that traditional military defense could not adequately protect. The Silent Strangler had proven that modern warfare could achieve decisive victory through industrial application of sophisticated weapons to economic vulnerabilities that conventional military doctrine had never adequately addressed.
The success of Operation Starvation in achieving Japanese strategic defeat through systematic mining operations established principles of economic warfare that would influence military planning throughout the remainder of the 20th century. The demonstration that advanced technology could achieve strategic objectives through indirect attack against economic targets proved more effective than direct military confrontation while requiring fewer resources and personnel than conventional operations. The systematic destruction of Japanese shipping through invisible weapons had proven that technological superiority could determine strategic outcomes through sustained application of advanced systems to carefully selected vulnerabilities that traditional military forces could not defend effectively. The age of economic warfare had arrived with devastating effectiveness that conventional military excellence could not counter.
Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.